This week, we're in the field talking about georeferencing of laser scan data. Now, if you've ever wondered how it works or why even bother to begin with, stick around for this week's episode of Trimble Forensics Tech Tip Tuesdays. Here at Trimble Forensics, we pride ourselves in providing a wide range of forensic mapping solutions, not just a one-size-fits-all approach to our product line. We know that the mapping of crash and crime scenes often involves more than just one set of circumstances that play to the strengths of a single instrument. That need to be versatile is something that we recognize, and we offer things like GNSS or optical total stations alongside of our laser scanning solutions to give you multiple tools for your toolbox. Now, laser scanners are a great tool, but having the ability to combine a laser scanner with a GNSS or optical total station instrument allows you to open up new and more efficient ways of combining different approaches to each and every unique scene that you're called out to. But one of the challenges with integration of laser scanning is how do we integrate these different technologies together without spending a whole bunch of time back at the office just hoping that we have what we need to make it happen? What if we could do it in the field, making sure that we have what we need before leaving the scene? The solution to this complex series of problems is the Trimble Forensics Capture software. So we have a large open area that's going to be difficult to map using a laser scanner unless we bring things to put out in the field to assist us with the registration. Plus, the evidence items are small, not likely to be discernible on a laser scan unless we spend a crazy amount of time doing ultra-dense scans of the area. No need. I have the Trimble R4 GNSS receiver, and I'm going to go map those small items with that using the Trimble RTK correction service. In addition, I'm going to place some arbitrary points around my scene to act as common points for our georeferencing later. Now that I have that done, it's time to break out our X7 to laser scan around some areas of interest. Now, this could also be the entry to a structure if you have a scene that you have evidence both indoor and outdoor. Now, I'm going to start with the Capture X7 plugin and get started scanning my scene. Now, while I'm right here, I'm going to use the X7's precision point feature to create annotation points where my GNSS points were measured. Now, this is going to come into play here just shortly. Once I have those gathered, I'm going to work my way around laser scanning the scene as needed. Now, keep in mind, the X7 scans are not yet georeferenced to my GNSS measurements. Right now, there's two sets of data. One is tied to the Earth. The other isn't. What we need to do is move the scan data to the GNSS measurements, or georeference our scan data. To do that, I'm going to go into my measurement menu and select georeference. Now, the Capture X7 plugin is going to bring in my GNSS points automatically. Then, compare the spacing with the annotation points I gathered with my X7. Once it finds a match, it's going to give us the result. Now, as usual, the best way to do this is with multiple points rather than just 2 or 3. That way, if one of them is off, you can discard it from the solution and still find a good fit. Now, I like to gather 5 or 6 just to be sure that I have enough to find a good solution, rather than having to go back and have to do it all over again. The georeferencing feature makes quick work of laser scan alignment to other mapping solutions. Now, as you can see here, we integrated a GNSS instrument with a terrestrial laser scanner in the field, rather than going back to the office. This ensures that if there's something wrong, we can go back and we can fix it before releasing the scene. Now, we can also georeference our scan data to an optical total station measurement log, using the exact same georeference function. However, the link between the scan data and the surface of the Earth won't be quite as accurate as with GNSS. Now, keep in mind, the georeferencing of laser scans to GNSS points will allow you to put your laser scans on the face of the Earth with a high degree of accuracy, if you are using the N-Trip correction service or Trimble RTX corrections. Now, if you're using a base and rover setup, your scene's exact position on the face of the Earth is not quite as precise. However, if you're using N-Trip or RTX, your scans are georeferenced to a survey grade level of accuracy. For more information on GNSS corrections, we're going to throw a link to the previous Tech Tip Tuesday where we talk about the correction services available. Now, let's look beyond the crash scene itself. Georeference data can be shared with roadway engineers or others that can use this data to build better roads and intersections and may help reduce the number of crashes that happen there to begin with. Or this tool may be a way to help justify funding for purchase of these instruments within your state, county, or municipality. One way to make use of this georeferencing feature is to use the Trimble Clarity service to share your georeference point cloud data with roadway engineers, or recreate the scene in the exact position that it was the day that the event occurred. Hopefully this video helped explain the georeferencing feature within Trimble Forensics Capture. Now, if this was helpful to you, be sure to give us a thumbs up so that we can make more videos that are pertinent to you. Also, if you have a question or have something that you would like to see on Tech Tip Tuesdays, write it in a comment below. Stay safe, and we'll see you all again next week.